In this video, we're going to build a Python function that retrieves the complete Binance Futures Exchange information and converts it into a clean Pandas DataFrame. By the end of this tutorial, you'll have access to trading rules such as tick size, step size, minimum quantities, supported order types, price precision, and much more. These info is really important essentially for order management. Before we begin, it's important to mention that the non-authenticated_request function was implemented in a previous video of this series. In that tutorial, we built a reusable function for making public requests to the Binance API. In this video, we'll simply reuse it so we can focus entirely on the exchange information endpoint. Now we define the main function. Its responsibility is to retrieve the exchange information endpoint and transform the response into a structured data frame. One important thing is to documentate the function properly for a better future use. You can see all properties on Binance documentation, such as endpoint, requests, IP weight, response. This endpoint doesn't require any parameters. Even so, I keep the same structure across every API function because it makes the entire project cleaner and much easier to maintain. Now we perform the API request. Notice how all the networking logic has already been abstracted away into our reusable helper function, making this implementation much simpler. Before processing the response, we first verify that the request completed successfully. If no valid response is returned, we simply return an empty data frame. Binance returns a large JSON document containing a considerable amount of information. The section we're interested in is the list of symbols, where each futures contract is described individually. We now iterate through every futures contract returned by the API. During each iteration, we'll extract the information that interests us and build one row of our data frame. This is one of the most important parts of the implementation. Binance stores many trading rules inside a list called filters. Instead of searching through that list over and over again, this gives us immediate access to values such as tick size, step size, minimum notional, quantity limits, and many other trading parameters. Here we extract all the information we want to preserve. Besides the basic contract information, we also store trading restrictions, precision values, order types, quantity limits, and several additional parameters that are extremely useful when developing automated trading systems. All obtained data from current symbol must be added into the created list that will support the creation of the data frame. Once every symbol has been processed, data frame, and return the final result. Most applications don't need information for every available contract. That's why I also created a helper function that allows us to retrieve data for one symbol or for a list of symbols, making the function much more practical in real-world projects. Finally, let's test the function. In this example, we're requesting information for all futures symbols. As you can see, the resulting data frame contains all the trading rules required to validate orders and build reliable trading applications. In this video, we've transformed Binance's exchange information endpoint into a clean and reusable Pandas DataFrame. This function will become one of the core building blocks of our Binance Python library. In the next video, we'll continue expanding this library by implementing another Binance endpoint and following exactly the same architecture. If you're following this series from the beginning, you'll gradually build a complete Python library for interacting with Binance Futures, one endpoint at a time.